So we got connectivity issues going on for poor Christopher. They're having difficulty and I'm sure he's stressed out. I'm just going to introduce you, Francis. So I'll let you take it over. I'm going to stop sharing my screen. And essentially, we're really excited today to hear about kind of the big picture of what Planet is. And then if you could talk specifically about use cases and how different groups are using your data and maybe give us ideas of ways that students and faculty can acquire and then use your imagery. That's kind of what we're interested in.
That sounds good. Hi, everyone. Good afternoon. My name is Francis. I am the account executive that covers Georgia. And on the call actually is my colleague, Uday Govindswammy. Uday, you there?
Yeah. Hey, everyone. Cool.
Yeah, wanted to introduce Uday. Uday is my colleague and he works in the education and research sector. We're both going to be tag teaming the presentation today. He's going to be taking a deeper dive as to how other universities are utilizing our data today. Talk a little bit about our satellites in space, our private constellation. And yeah, we want to keep this super interactive. So anytime you guys have questions, feel free to unmute or write in the chat screen and we'd be happy to answer that. But Uday, I'll let you take it from here. Enjoy, everyone.
Cool. No, thank you for that introduction, Francis. I always kind of like to start with a quick introduction of kind of my experience slash, where I've come from. So I graduated out of Scripps Institute of Oceanography in UC San Diego. Have a little bit of a remote sensing background, but have been, working with Francis very closely on targeting universities and other universities and bringing in planet imagery into their systems. What's been really exciting with Planet, let me see if I can actually get into presentation mode first. And then, view, there we go. Okay, can everyone see the slides?
Yep.
Cool. So yeah, just to preface it and start, this dialogue, if you feel like you have a question or want to pause me at any given point to understand a little bit more about the use case that I'll dive into, definitely feel free to unmute yourself and pop questions in the chat box. Francis, if you can kind of keep monitor and tab on that and just pause me whenever, totally cool with that. So yeah, just to start with everything, Planet's a satellite imagery company. We have about 140 breadloaf-sized satellites orbiting around space, taking near daily images of the Earth's entire landmass. We also have these high-resolution satellites called SkySats that are kind of more in the traditional tasking mold, taking images, point and shoot / your typical tasking kind of satellite constellation imaging system. So the combination of the two has kind of led us to be one of the leading geospatial companies globally. And we're super stoked to kind of be here. And it's a big homage and testament to our founders. When they came into the company, they were two NASA Ames engineers. There's like this running story that they would go to the board investor meetings with the satellites in their backpacks. And then, the investors would be like, all right, show us designs and, basic prototypes of the satellites. And then they'd pull out of their little like mail bag a satellite, which was essentially one of the first imaging CubeSats. And investors were absolutely shocked. They were like, how is this going to image the world? And the most exciting part is because of the size and the micro nature of everything that's within those satellites, it's enabled Planet to kind of really break the space and literally, produce 140 satellites / more satellites very quickly and agilely. And it's a big part of our emphasis, our approach, our focus, and has enabled us to kind of, reiterate and make changes and, add more features to our satellites every couple of years. So what you are seeing today wouldn't necessarily be something that, Planet's doing tomorrow / kind of years onward. So we're really excited about that ability to iterate fast, kind of match with the market. And it's really unopened and really leverage and produce amazing research results. So in 2017, the founder's mission was to kind of create this idea called Mission 1, which was essentially let's image the Earth at a near daily basis. So Planet essentially captures the Earth's entire landmass nearly on a daily basis. So when I say daily, you're probably talking around 4 to 5 images every week, which is really exciting because it's the first kind of multispectral constellation that's provided this nice enough resolution where you can actually monitor environmental change, but at the same time also providing that cadence that systems like MODIS that basically are applying, but on a much finer scale. So yeah, that kind of skips into the 2 major constellations that we have, which are PlanetScope and SkySat. PlanetScope is our kind of flagship / constellation that we're more famous for. Within PlanetScope, the resolution of it is 3.7 meters. It contains a red, green, and blue band, a red edge band, a near infrared band, and our newer generation doves will actually be releasing 8 bands. So we're adding a coastal blue band, a yellow band, and a second green band, which is really exciting from a sedimentology perspective, as well as any kind of coastal related studies with aerosol application, as well as kind of tracking watershed and hydrology. So we're really stoked to add those and see, the kind of research insights that are unlocked with that. Looking at SkySat, it's the high-res tasking constellation. So typically you'd see it imaged over urban areas, infrastructure, geopolitical issues. Those are kind of more aligned with the use cases you'd see with SkySat, simply because the way I kind of like to compare it is PlanetScope, you can see cars. Sorry, with PlanetScope, you can see houses, you can see roads, but then with SkySat, you can see cars. So kind of skipping on to our education research program. As a company, and this number is already outdated, we actually have 800 peer-reviewed conference papers since 2016, with a new publication being produced every 48 hours. It's super exciting to see so many researchers on a global scale using our imagery and integrating it within their workflows. So here are some of the more notable universities / programs that do have our imagery. Programs such as Greg Asner's program out of ASU, Stace Maples' Geospatial program in Stanford, the University of Maryland NASA Harvest program. So there's some really exciting universities doing some very innovative research amongst the realm of remote sensing. So yeah, this is kind of just a quick map of where we have some of our kind of expanded licensing options. We have multiple software packages per se that as universities you can integrate to expose students to the imagery. And we also have basic individual user applications too. So I'm gonna skip through to the SDGs. Planet is, a firm believer in sustainability. We are trying our best as a company to support other companies to track themselves and how they are matching up with their sustainability goals. Now, by integrating Planet into your workflow, it doesn't suddenly magically make you more sustainable, but what it does is it provides a mirror and it provides a lens to highlight your sustainable actions. This, from a policy standpoint, from a consulting and environmental compliance standpoint, is essential because it provides companies as well as NGOs, users, the ability to use Earth observation data and highlight how companies are aligned with these SDGs. So here's a direct quote that we actually received from the Deputy Secretary General from the United Nations, who believes that Planet can contribute and basically help evaluate 13 of the 17 SDGs. And it's super exciting because we have very deep tie-ins with the UN. From a global context, we're trying to actively support a lot of their initiatives, as well as with university and researchers. It's definitely a huge contribution. From Planet's side, we're working closely with Jeff Sachs' group, as well as Gordon McCord from GPS in UCSD. So it's really exciting because there's a lot of cool cross-collaborative initiatives integrating Planet data to help kind of track these SDGs. So this kind of transitions into one of the first research use cases that I wanted to talk about today. So Planet imagery is, this researcher was using Planet imagery to basically track plastics and plastic debris formation along the coastline of Indonesia. It was really exciting because the researchers essentially used multispectral imagery and then simple band map to basically evaluate where plastic debris accumulation was kind of forming. Here is another use case where we kind of dive into how the sedimentology and turbidity within Venice had specifically changed. So before the lockdown, when you look at this side over here, you can see it's deeply dense and there's quite a bit of sediment just in general from a density standpoint. And then as the lockdown progressed and you started to see a reduction in boat movement, in people movement, as well as just general traffic, you can see there's an obvious change in suspended solids, which is super exciting because it actually resonated and highlighted a lot of the local wildlife coming back into Venice, which is why if you look at some of the recent YouTube videos from Venice before kind of right at the start of COVID, once people were kind of not as flowing / not life wasn't really back to normal, you could actually see a lot of the wildlife returning to those areas. Here's another really relevant use case where researchers are using planet imagery as well as foresters are using planet imagery. So one of the leading causes of forest fire is actually bark beetle disease. So specifically this beetle, as well as many other beetles / various other bugs have gone into forests. They essentially have kind of eaten the trees and caused a lot of dead trees. Now, typically before forest fire seasons, forest agencies have to cut down these trees and monitor a lot of these dead trees because they're essentially just fire fuel. So actually this year with the Forest Service in California specifically, they unfortunately didn't have the same kind of monitoring systems in place. So they didn't have the ability to actually go into the forest and cut down a lot of these trees, which was one of the biggest leading causes for such an intense fire season this year comparatively to previous years. So other nations like the Forest Management Institute in the Czech Republic, as well as this timber harvesting company right here, have been integrating planet imagery into their workflows to kind of track these disease outbreaks. And typically, if you can track them earlier rather than later, you can actually cut down a lot of these trees and basically safely harvest them away from the forests to essentially create these healthier systems. So that way, if a forest fire does happen, there's less fire fuel to kind of work with for a lot of those incidences. Here is another really interesting use case where we kind of look at Lake Erie in Ohio, and you can actually see the algae blooms using planet's imagery. So kind of looking at this back and forth, you see a difference in 3 days and this massive expansion of algae just kind of occurring in the area. Now, with areas like Florida, typically where there's wetlands, you tend to see a lot of these algae blooms as well. So it's really exciting for a lot of the wetland-based areas to kind of monitor and check for algae using our imagery. Here's also another super interesting use case, one that I'm personally very attached with, is the Allen Coral Atlas. So Planet's imagery actually helps support a lot of the base layer imagery that's included within the Allen Coral Reef Atlas. So it's essentially this map of all the coral reefs globally, and they all use Planet imagery as a data layer within that imaging system. What's really exciting is the Allen Coral Atlas has a bunch of sonars and instruments that they're using to essentially evaluate algae health underwater, and then they're combining it with satellite imagery. So you can kind of look at this over here, and you can see how the Allen Coral Atlas has basically created this differentiation between different types of sedimentology as well as coral. And it's super exciting. You kind of see the fusion between satellite imagery as well as ground truth data that's been collected by boats along these coral heavy areas globally. Here's another study that was done specifically from Greg Asner's lab at ASU. So Professor Greg Asner essentially did a LiDAR scan from the years 2011 to 2013 of the entire Peruvian Amazonian forest range. He did this to basically calculate carbon density of that entire forest range. But the really exciting part is he actually integrated planet imagery to model the change of carbon stock emissions. So within the Amazon, obviously deforestation is a huge issue. So it was really exciting to kind of see Professor Asner integrate Planet's near daily technology and then essentially use that to model the changes in number of trees, and then use his LiDAR data to essentially calculate how much carbon was reduced from a lot of those areas. So the idea with this is to now potentially expand it globally, this methodology globally. And what's really exciting is with missions like 3DEP, as well as NASA's JEDI program, the US is going to have a lot of updated LiDAR imagery from the years 2018 to 2022. One of the flaws cited in this study was the data for the LiDAR collection was taken from 2011 to 2013. Now, there was huge changes to the carbon density / the forest areas within those years. So now having this updated LiDAR imagery combined with Planet's near daily / calibratedly better imagery is super exciting, because you can actually integrate a lot of these methodologies and you can do it with more relevant data. And companies like Salo AI, Pachama have commercialized these methodologies and are starting to expand them at a global basis, which is really exciting, because you're starting to see the California Forest Observatory work with a lot of these companies and really get a true understanding of forest health. So kind of diving back into the SDGs, here are some direct examples of how Planet's imagery can help with them. So this ties back to the Asner study, specifically can help with the SDG 15, the life on land. You have infrastructure monitoring over here, where you can kind of see changes to land use. And through that, you can actually, I think this study specifically was using a combination of populations or census data combined with Planet data, and was seeing the introduction of new infrastructure and developments. So you can see the trend slowly rise as urbanization increases. Down here, another key SDG, same SDG as the first one with, the second one with 11, is we can also help with creating flood maps. Now, Planet's imagery doesn't provide topographic readings. It's not really a DEM, but it provides change / extent and can be a valuable data layer that's used within a lot of flood maps. Google specifically through their flood / data initiatives program uses Planet as a data layer for some of their flood map modeling as well. And then this last one is a really interesting study done by Carbon Tracker, where they've essentially looked at a bunch of the coal-fired power plants globally, and they've used Planet imagery to track plume size, and through that kind of evaluated changes to pollution as well as carbon. A little bit of a wonky study, but still super interesting, and I think really relevant from a data tracking perspective. So I wanted to kind of open the floor for questions, and specifically for this section. So what do you see here? What are we looking at? Feel free to unmute the mic and answer away.
Uday, there is a question that popped in earlier
nice.
from Alex. He said, with growing interest in space travel and global monitoring via satellites, I imagine there's a lot of growing concern about satellite traffic. How long do your satellites stay working, and what happens when they stop working? Good question.
Yeah, that's a great question. So NOAA has actually installed a lot of regulation that's for satellite companies to have what's it called? It's like their basically depaneling systems where they come back down to Earth safely. So in order to kind of reduce space debris, and it's been really interesting, obviously, with more satellites, especially more CubeSats with Tesla SpaceX launch, as well as, you definitely see a lot of launches globally through Astra's program. You're definitely starting to see more smarter systems and space regulation being implemented that prevents companies from, or makes companies deorbit their satellites properly. And our company has deorbiting systems that we kind of have in place. I believe other companies do too, but it's definitely part of the parcel. And, you know, with a lot of the older satellites from the 70s, the 80s, the 90s, you definitely have a lot of space debris that's kind of just orbiting around Earth. And, you know, there have been all these really cool companies and innovative strategies to kind of help get rid of those, as well as, you know, making sure that what we send up isn't polluting any further / adding more problems. And in part, it's a little scary too, just because, you know, the fear of a satellite debris just kind of orbiting and hitting your satellite. So our engineers are actively looking into, you know, ways to kind of evade those space debris that are just kind of floating, and making sure that, you know, our satellites aren't in crash collision courses or paths with the others that are already up there too. And a lot of that's regulated by NOAA as well as NASA. They do a lot of work on that space policy side of it. Cool. Do we have another question? I see the chat box popping up.
I was mostly just prompting people to take a guess about your image.
Nice. Yeah. So what are we seeing? Feel free to unmute yourself, put answers in the chat box. Oh wait, where is the?
Hal took a guess. Thanks, Hal. I love you. Yeah, I think that's a pretty good, guess there. Anybody else have one? I bet a lot of people have it like on the tip of your tongue.
See it. Change traction seems to follow. Okay. Well, I'll take that silence as you're taken away by what I'm saying, but so to kind of highlight, it's a lot of things. You know, with satellite optical imagery, you can't necessarily derive as to what the exact problem is. I think even with that pest detection slide, you can just see if the tree's alive or dead, but you can't know if it's pest detection versus it's not pest detection, or if it's an invasive species. Now, it gives you clues as to what the problem will be. To really make the value of satellite imagery come to life, especially you know, optical imagery that's not SAR or that's not including an active sensor, you have to integrate other data information layers, including weather forecasts, understanding crop history, like what crops were planted in these areas, understanding changes to soil moisture content through your own IoT sensors, but really developing a sense of other data to complement satellite imagery. To us, we recognize we're a piece of the puzzle. We're not the end all say all. If you have planet imagery, you're going to be able to solve all your problems. But it's understanding what data layers are essential to track a lot of those problems. Now, here's a quick overview of what the resolutions look like, and, you know, kind of highlights how planets really come into action / handy for a lot of agronomists, researchers, users globally. So this is specifically a crop field. You can see over here with Landsat, that's the resolution that you get. So Landsat and Sentinel are the open source imagery options that are available freely. Then you have PlanetScope, which you can see the field, you can get general vegetation health, but you can't calculate individual trees now, or individual vines or crops. But with SkySat, the 50 centimeter resolution that we have, you can kind of see those individual trees / you can see those individual crops. So the way I kind of like to describe it is, you know, with vineyards, with walnut orchards, with kind of your more tree-based, if you're trying to do individual tree counting, you typically use SkySat. But then if you're talking about general vegetation health and large-scale countrywide environmental analysis, you tend to steer towards PlanetScope. And really understanding what you can see at each resolution and what insights you can derive from each of them, I think is essential for any researcher. So to kind of dive in a little bit more about some of the other really interesting studies that have been happening with Planet. Over here, you can kind of see how researchers have used planet imagery to monitor the geosphere. This study over here essentially was using planet imagery to see slow scale changes to the fault line for the San Andreas fault line specifically. Over down here, you kind of get a look at this really interesting study that was done where they essentially use planet imagery to map out watershed. Over here, you have the kind of landslides that triggered the Palu earthquake. And what the researchers did over here was they evaluated kind of slow scale changes to fault lines. And they saw the lead up to the bigger event, typically with a lot of big Earth/geosphere related natural hazards. There's typically a slight buildup in, force or formation, and understanding when those events are happening and the buildup to a larger event is essential to kind of model and predict future larger events. So yeah, can I go into the next slide? This is the kind of researchers that have used Planet to study atmosphere. So this paper over here, I think it's super interesting. It's one of, I think, the finest papers that's been produced with planet imagery, but it was produced from a university researcher out of Duke University, Tongshu Zheng. And what Tongshu did was essentially he used planets, he looked at all this imagery in Beijing specifically, and he looked at the haziness in an image and included measurements on the ground. So he had air quality sensors in Beijing that he'd basically extracted data from and compared his methodology to those on the ground sensors. Now, one of the commonly cited problems in air quality measurements is you can get air quality measurements for large scale areas, but you can't really pinpoint point source solutions / individual areas that are producing more pollutants comparatively than others. You might be lucky if you have access to local factories, on the ground sensors, but usually that's not the case for most government agency air quality monitoring bodies. So what Tongshu did was he essentially used the haziness in an image and used that to actually calculate PM 2.5. And he used a neural net as well as a random forest approach. And it was super exciting because he basically created this really amazing methodology that managed to pinpoint solutions or pinpoint PM 2.5 to 200 meter by 200 meter grid boxes. The most exciting part about that was you could essentially pinpoint point source solutions with those kinds of measurements. And it's a scalable solution. That's something that we've talked to various folks at LA City, as well as other air quality monitoring boards. And they're really excited to potentially integrate these types of methodologies in combination, in conjunction with their on the ground sensors. So yeah, and then the bottom section over here is a very cool cloud masking algorithm that was created from a neural net where one of the researchers essentially used past year imagery with our imagery at Landsat and Sentinel, and then created this cloud masking function, which is really exciting just because we all know as remote sensing scientists that clouds aren't anyone's best friends unless you want to measure certain cloud related features and functions. So here's another exciting usage specifically within the cryosphere. So Planet's actually been recording many parts of Alaska, northern Canada, West Greenland, and there are actually a couple of PlanetScope frames over the Arctic as well as Antarctica. Now, from a coverage standpoint, it's substantially lower than that near daily kind of temporal resolution that we're better known for. But it's really exciting because it's a lot of researchers' first real exposure to working with data at a lot of these kind of cryospheric regions. And because of the temporal cadence over certain areas and kind of the signatures with ice that you don't see with other areas. So let's take, with rivers, right? within a lot of cryospheric areas, there are a lot of ice kind of bits that flow within those rivers. So this study over here, they essentially they were looking at planet imagery, and they were looking at the flow of these kind of ice bits within a river. And then by seeing where it was one day, comparing it to the next day, they could actually track river velocity vectors. And through that, they could get the speed of the river, which was really exciting, super innovative, and quite relevant to a lot of areas that are, within cryospheric regions that have fears of flooding risk. So this is probably, the most exciting part and the kind of future of where planet's headed. If we had a pseudo mission 2, as I kind of jokingly like to call it, it's the commercialization of data fusion products. So a lot of researchers have been kind of looking at new methodologies to create these cloud-free, atmospherically corrected, seamless photos that you kind of see with the typical mosaicing options. And for those of you that aren't aware, mosaicing is kind of this process where you essentially stitch together the best pixels from either a month or a week, and you form these images that are kind of really easy to work with and don't have differences in coloration and haziness, and they're kind of seamless. Now, what a lot of researchers have been looking into is how can we create mosaics, but how can we create it on a daily basis? So a lot of researchers across the board have been looking at new methodologies into this concept called data fusion, where they essentially fuse together multiple data sources to create these images that are seamless, easy to work with, and don't have a lot of the same issues you kind of typically have to deal with near daily imagery. It's quite funny because it's ironically a problem that we have caused by adding so much more data to the world. But I think in return, this is our way of trying to kind of create geospatially analysis ready data. So these two research papers kind of dive into these really interesting, innovative data fusion techniques where they essentially combine planet imagery with sentinel imagery, at least this one at the top. And then through a CNN, they create these really amazing pictures and then resolve them to a slightly higher resolution in this case. But obviously you don't necessarily have to do that if you don't have to deal with the resampling aspect of it. So our company has created this data fusion algorithm slash the founder of the algorithm, Rasmus Hoberg, actually came out of our education and research program. So before this algorithm that he created, which originally was called CSTEM, you can kind of see that there's slight differences. There's cutoffs, and I think I actually have a better image of it right here. So this is what it looks like before, when you're typically looking at a single scene, you kind of see clouds, you see cutoffs in the images, you kind of are, right? You're probably getting one good image every couple of weeks. Now, sorry, not a couple of weeks, couple of days. But then you integrate this algorithm and you get this seamless image that basically doesn't have any clouds. It corrects for the atmospheric issues that were kind of listed over here. And then you also have, the beautiful surface reflectance map right here. Now, what's really exciting about this is it creates this standardized L3 level. So typically when you're dealing with raw imagery, this is known as L1, mosaic imagery is known as L2, and then this CSTEM gap-filled image is known as an L3 layer. Now, you can, the really exciting part is you can start to integrate SAR imagery, LiDAR imagery, and other imagery and fuse that with this L3 data. But the key part is having this L3 data set so that the fusion process from the SARs, the LiDARs, the other hyperspectral sensors of the world come into play. You're starting to get temporally consistent, radiometrically consistent data that's really exciting and fun to work with. And from a finding standpoint, I think we're barely scratching the surface here.
Hey Uday,
So,
we have a bunch of questions just to chime in.
sure.
First one was, if you could track sediment flow down a river, you can also track movement and migration of people. Yes.
Ah, that's a good question. So typically you can't see people at 3 meter resolution. You can see patterns of life though. So when people move down river systems, they tend to leave signatures, whether it be houses, settlements, changes to vegetation. There is slight changes, like especially like large migratory bodies, when they're moving down rivers, they're moving with a lot of stuff. So those changes, you can pick those up with PlanetScope, which is really exciting because then you can in turn track the migration patterns, assuming the group is big enough. Now, if we're talking about one person moving from point A to B and they have a little tent, probably not. But if it's a group of 10 to 15 to 20 people, there's usually enough happening where that resolution is coarse enough to pick it up. Next
Alex,
question.
I know you rephrased your question, but does that answer
Oh,
it? Yeah, I think it.
population movements. Okay, cool. Yeah, there are actually quite a bunch. In Ethiopia, there's some really interesting tracking of these settlements called bomas. They're essentially these semicircular kind of living inhabited areas, and there's new bomas every couple of weeks. So people kind of migrate from point A to B and then create these bomas. And it's a super interesting study, and it's a lot of the time and the methodology that USAID uses to actually track spread of disease, because a lot of the time, you know, old diseases like polio, malaria, and derivatives of them kind of break out in a lot of these communities or these bomas. And the way you track that is by understanding the movement of the boma / the new developments of them. And if you don't have an understanding of where those locations are, it's really tough to gauge, you know, where can we send our resources in, because typically these areas are kind of in very remote, hard to get to areas. So if you're not sure about where you're sending someone, they could be going to the middle of the desert, and it could be very risky / you know, you're kind of walking into the realm of unknown. So yeah, really good question. Do you provide cloudless weekly, monthly composites of your data? So we do provide monthly mosaics in the departmental level license. We don't offer it with our basic license, but those mosaics are included with some of the more expanded options that I was alluding to at the start of the presentation, those 40 or 50 universities that also have those programs. So, cool. Any other questions? Sweet. Let's see if I can actually go back now. So kind of going back to the data fusion concept, what's really exciting across the board is there's so many new sensors coming up. The commercialization of and / the democratization of satellite imagery is continuing to expand on a day-to-day basis. You're starting to see new satellite companies with new sensors. You know, Hawkeye 360 recently launched their new constellation. You're starting to see Capella Space, they're launching SAR sensors. So what's really exciting is because of these new sensors, you're starting to see all these different data forms and data fusion techniques that people can integrate. Now, Planet, we believe, can serve as that baseline consistent data within all those fusion related studies. And with those newer measurements and readings, if you have, let's say, a SAR image that's taken the same time as a Planet image, you can actually model out what the SAR image would be doing by using consistent Planet images, assuming that they're shared bands amongst both of those sensors and satellites. So it's really exciting because, you know, we're starting to scratch the surface of all of this. I think as a company, we're super stoked to, you know, kind of lead this initiative and help pioneer a lot of these studies and commercialize this. And I think you're starting to see it across the board. Recently, BASF and Vandersat had this really cool sensor fusion kind of agricultural related product that they created with Sentinel imagery, as well as Vandersat's own in-house satellites. And, you know, Planet's going to have our fusion product called Planet Fusion, which basically is using that CSTEM algorithm that I was alluding to at the start of the fusion discussion. yeah, overall, it's a super exciting space, and we're stoked to be kind of one of the leaders of that. So the last slide and kind of what I wanted to share with all of you is, how can I get access to planet imagery? I know that was a question that we kind of, some of you had brought up earlier. So I included a QR code right here. This QR code, if you pull out your phone and scan it, links you up to our education and research page. And we have a basic application where you can apply for 5,000 square kilometers of either PlanetScope or Rapid Eye data. It's strictly just the raw, like the near daily scene. So it's none of the mosaic products, but from an exposure standpoint, and if you want to integrate it either into a capstone project, a PhD project / dissertation, definitely encourage you to do so and apply to the program. It does take us about a week to approve the applications, but it's a really wonderful way of getting exposed to Planet's data and starting to work with it from a long-term standpoint.
I just thought I'd ask the group, and thanks to Uday, before scanning this, was there anybody that was currently a user of Planet data? Just curious. Okay, I'll take
I
that
don't
as
think
a
so. One thing I was wondering about is access, and I think the question that just came in was relating to that too. I know you offer all these university arrangements and then some ways that are easy to access products. You also have a big license with Esri now. Is that right? How does that integrate into, like, say you're in ArcPro, our students are really familiar with all the ArcGIS suite or Arc Online or something like that. Is that integrated there? Or do you have this in like Erdos that you can just pull it in, or like which software would people use? What would that workflow look like is, I guess, my question.
So we have plugins with with ArcPro specifically, and then with QGIS as well. We also have a Google Earth Engine plugin coming up, but it's limited to a couple of areas. So from a study standpoint, if you're interested kind of in your own areas, you definitely would have to cross-reference with our plugin page if those areas coincide with the areas you're interested in. But I know for a fact our ArcPro as well as our QGIS plugins work very well. And yeah, they're great for you. You can basically work in your own local environments through those plugins and kind of just seamlessly get the planet imagery from the plugins rather than having to go through our own API, which is Explorer. So we have this kind of Google Earth looking API that you can also download images from. It's a little more easier to use if you've never used any GIS programs, but I'm guessing with the name of the club and the people we're talking to, the audience is very well versed in using ArcGIS as well as QGIS. So yeah, overall,
you're pushing Earth Engine more and more, so I'm really happy to hear that future implementation.
Yeah,
even if it's just regional. Are there like kind of cookbook style tutorials or things available for educators to just use and implement in their classes?
Yep. So we have a developer center, which is basically serves as like the Planet 101. It has a lot of basic API documentation. What a lot of users have done in the past is they've kind of, like, the instructor, professor will go through that developers page, develop an initial exposure / idea of how to use Planet, integrate Planet, and kind of use it within a lesson plan, as well as kind of share and teach with the students what's possible with it. And within that page, I believe there are videos, YouTube videos / tutorials as well. But at the minimum, there is documentation that clearly and explicitly states how to work with our imagery. So yeah. And there's also a discussion community forum. So if there are, let's say, outlandish questions or stuff that a student can't necessarily, and the professor can't necessarily answer for a student, they can just post on those discussion forums. And then through that, a person from our support team will help kind of answer some of those. So, yeah.
There was another question that came up, Uday. How does your API operate? Is it simply data querying, fetching with processing performed locally with whatever language, software, or do you provide cloud computing capabilities as well?
So you typically as a user would have to download and store the imagery in-house. We can, like, from a view, if you want to view the imagery, yes, we're hosting the imagery for the initial point, but once you want to run your analysis or algorithms and various code scripts on, you definitely would have to download it. So we don't do any of the physical cloud storage. From a API process, I would definitely just refer to our developer center / that area does have a lot of, I guess, literature on how to, best practices with Planet and highlights how our API works. So yeah, and I can, I'll include that in the link and send it in a follow-up too. Developers Planet. Cool. Just pulling it up. Where's the chat? Cool. Sweet. I guess, are there any other questions I can go through? Spoke a lot, so.
I've been stuck rattling my brain around the flood zone or flood risk analysis from a while back. So when y'all analyze that, do y'all use previously recorded DEMs and previous knowledge to kind of assess change over that period, or how does that necessarily work without using a DEM?
Yeah, that's a great question. So typically it is, you're using data from DEM data that's been recorded or that is open sourced around those areas. And then it is modeled, or the rate of change of, the flooding event / the water is modeled using the Planet imagery. So the way I like to take it is the DM's the baseline data, and then you use Planet to kind of model, okay, the water is here versus here. We can kind of deduce that there's X amount of water. This is the rate of change. Now we can kind of calculate volume flow of the flood as well.
So, I mean, I guess is what I'm getting from it is that Planet, y'all as a company and all, y'all don't necessarily want to repeat what everybody else has. Y'all want to add something to the table, essentially, for better sense of it for me. And so, I mean, y'all are just using DEMs, and instead of making your own DEMs where they're already readily available, y'all are just adding that extra oomph to the table.
Correct. The way we kind of treat it is, we're kind of the data providers of the day-to-day change. And then the users, the researchers, between open source imagery, between LiDAR imagery, DM surveys that already exist, can really unlock the value and potential of it. From a researcher standpoint, these are all researchers that have produced findings that have nothing to, they've worked with Planet data, but they don't work with Planet. So that's the most exciting part. It's researchers globally kind of working with their own set of data sources, and recognizing and acknowledging this is where Planet fits into that holistic puzzle that you were alluding to. But yeah, it's definitely, I a lot of the times I wish we could tell customers we do DEMs, but in all honesty, we don't. So we do have a stereo product with SkySat, and some folks and really technical, like I think DEM / 3D generating leaders have produced actual DEMs from those stereo images, but it's like some really wonky, very dense, deep research. So it's possible. I've seen people do it, but it's not something I'd steer you on a path on unless you wanted to kind of commit your life to it. So yeah.
Yeah, no, that's awesome on how y'all just kind of add to the table opposed to just kind of recreating something that's already there, essentially, in an open source realm. So I mean, that's definitely awesome. Y'all use that to your advantage.
Definitely. Any other questions?
I had a question, and this might be for you, Amber. I mean, just kind of wanted to get like a good gauge as to the listeners in the room. Is everybody students? I mean, are there like researchers or faculty that are present as well?
Yeah, we have a good mix here. I see like 5 or 6 faculty, although it's kind of ebbed and flow over time. I think I'd mentioned in one of our prior conversations, oddly, we've been doing face-to-face classes since last August, which I know you mentioned that you weren't aware of many other schools are doing that. So some people are teaching right now and in classrooms, but we do have a lot of students here, some upper level, some who are kind of new to our institute. So it's kind of a mix from the names that I'm seeing. Yeah.
Cool.
And a lot of the faculty, and you are welcome to speak if you would like to, do a lot of water resource studies. So what you mentioned, as soon as you mentioned Scripps, I was happy about that. We have a faculty who went there as well.
That's awesome.
And I think a lot of those applications were very relevant to the type of work that we're doing here.
Wonderful.
Yeah.
Yeah, whole point of today was just to scratch the surface of what's within the realm of possible. Get you all ideas on how to do stuff with Planet. So
yeah, no, I appreciate it. I think there's a sort of awareness of the kind of cool data that you have available, and the resolution and the daily, like that's just amazing, or semi-daily, I guess you should say. Yeah. But also there's just so many times that students will have a great idea and then not be able to get the spatial resolution and temporal resolution that's needed. I mean, that's like one of the most common things when they're designing projects. So if we had better access to something, I think it could help a lot.
Definitely. No, that point you bring up too, I think about just temporal resolution as well as just general visible resolution. It's essential for a lot of the environmental scale application research that so many of us want to dive into and do. And you know, for me, the light bulb moment was I actually used to do coastal oceanography, and I did a geological study over the Mission Bay littoral cell, which is like the San Diego coastline. And I was kind of walking along, manually taking photos, like with a camera along the coastline, and I was kind of walking on these really like slippery rocks, and you know, I was the only person for a lot of those moments, and realizing that I'm like, shit, I could potentially, like, you know, if I fall, anything happens, I'm screwed. And kind of seeing that Planet's a solution that enables you to do a lot of these things without actually having to send someone to a lot of these risky areas, it all kind of clicked. It was like, wow, this would have been such a more efficient way of doing it, as well as really, you know, the ability to see time and change. I don't think you can really do that if you're on the ground, unless you have sensors on the ground. And a lot of the time that can be pretty expensive. So, yeah.
Right. Yeah, we have a lot of, so mentioning the water remote sensing, we have a lot of, you know, fresh water that we're looking at here. So if you think of all of these inland water bodies, and a lot of them are pretty small lakes and ponds, and they get full of cyanobacteria and really funky and are interesting to look at. One of the questions I saw just pop up too is about
the 8-band.
Some of those additional bands, which will allow for even more investigation. But we're often pixel limited when we try to look at some of the small ponds. And we have tens of thousands of those all across the landscape, these little farm ponds. So anyway, that's exciting.
Yeah, no, so the 8-band should be available, I believe, in May. That's the loose timeline right now. Honestly, I pitch it really being available in June, knowing the way timelines work within our company. But yeah, I think, you know, it's really exciting just adding that coastal blue band for aerosol application, as well as some of the really, like, apparently you can track whales with coastal blue. And then, you know, with I think the yellow band is going to be key for sedimentology related research around water and turbidity. And then the second green band will be really exciting for a lot of those cyanobacteria related studies you were alluding to. So.
Very good. I know, Owen, I just saw you pop on. I don't mean to pick on you, but Owen's currently doing work with the NASA Develop program. And I know that you were looking at doing some data fusion. Do you know if Oh, go ahead.
I can allude to that. Yeah. So we actually have a CubeSat program with NASA. So if you are a NASA funded researcher or have a NASA funded project, you can apply for Planet imagery through that contract mechanism. Now, another contract mechanism that we do have available too is if you're interested in doing studies within the forests, like in the mid latitudes, predominantly tropical areas. We have a data program with NICFI, which is the kind of Norwegian overarching forestry council that monitors forest health globally. And they're one of the leading countries, Norway in general is one of the leading countries for forest health. So we do have a data program that enables you to access some forms of our imagery through that as well. But yeah, with the NASA program, it's strictly for NASA funded research. So if you're just generally applying, probably not worth it. But if you're within the NASA developed program, I think you should be able to access it through that. And definitely feel free to pass through my contact information and I can link you up to our NASA program manager and they can help you get set up, especially if you're working with NASA developed. So
That's helpful.
Well, just wrapping up, are there any more questions that we might be able to answer? Thank you for everyone's time, but yeah, is there anyone else?
yeah, one thing we can also look into, obviously we didn't really dive into those departmental and campus-wide options, but Francis and I would be happy to set up a second presentation and just walk through those options and what's available. And then even, with NASA develop as well as, with the NASA contract and the NICFE contract to share what you can get through that, because each of those vehicles / mechanisms have their own benefits and cons. So just kind of listing through each of those, I think might be really fruitful for professors or PhD researchers that, are really interested in learning more.
Okay, yeah, that sounds good. We'll have to go move it to another day because I don't want to.
Yeah, that's okay.
And but yeah, I really appreciate it. And I'm glad you mentioned the forest applications. We have Natalie and Jacob here looking at just that kind of stuff. So, okay. Well, thanks everybody for coming on to the Zoom. We'll try to have some more Zoom seminars, maybe another one next month. And I'll be in touch with some of the Planet folks. We really appreciate your time.
Thank you, everyone.
Thank y'all very much.
Thank you.
Thank you.